Hello everyone, welcome back to Kapil Joshi tutorials. Now imagine a farm where drones monitor crops from the sky. Robots work automatically in the fields. Tractors make intelligent decisions and even cows can communicate important information to the farmer. Let's imagine. So it may sound like as a futuristic farm, but these are examples of how advanced technologies are transforming modern agriculture. In this video, we will understand the major opportunities created by deploying advanced technologies on farms. So, let us understand the concept step by step. Let's start with survey drones. In traditional farming, farmers usually inspect their fields manually, but when the farm is very large, checking every part of the field becomes very difficult and time consuming. With drones, farmers can capture aerial images of large agriculture areas. So these drones can help in monitoring crop growth, field conditions, irrigation equipment, crop streets, and possible disease affected areas. For example, imagine a farmer has a 100-acre farm. So instead of manually walking through the entire field, a drone can survey the area and provide useful visual information. When drones data is combined with artificial intelligence and machine learning, the system can potentially identify unusual crop patterns and help farmers make faster decisions. So the first major opportunity is better monitoring and less time and efforts. Now, fleet of agri-robots. The next technology shown in the image is a fleet of agriculture robots. Robots can perform different agriculture activities with reduced manual intervention. For example, planning, monitor, weeding, spraying, and harvesting. Instead of using one machine for every task, a fleet of specialized robots can work together. So think about it like cricket term. A cricket term has different players with different responsibilities. Similarly, in agriculture, a robot fleet can have different machines designed for different farming activities. So one robot may monitor crops, another may remove weeds, and another may perform field operation. So this can improve automation productivity and operational efficiency. The important idea is that agriculture is moving from traditional machinery toward intelligent and autonomous agriculture system. Now the farming data. Now let's look at the farming data. This is one of the most important component of agriculture farming. Like we are talking about smart agriculture farming. So modern farms can generate huge amount of data from sensors, drones, weather information, soil measurement, machinery and crop monitors system. So this data can be analyzed to understand what is happening on the farm. For example, suppose soil sensors detect that a particular area has low moisture. Instead of applying the same amount of water everywhere, an intelligent areas like I'm talking about, the system can help identify the area that requires more irrigations. This leads to the concept of data-driven agriculture. The farmer is no longer making decisions only through experience. So instead, decision can support by real-time and historical data. Now comes one of the most interesting technologies in this image, that is texting cows. Don't worry, this doesn't mean cows are usually using a smartphone. The idea represents the use of sensors and connected technologies for livestock monitoring. So sensors can collect information related to animal activity and behavior. For example, change in activity may indicate that an animal requires attention. So this information can then be communicated to the farmers through a digital system. So instead of continuously observing every animal manually, so farmers can receive alert and useful information. So this is an example of how IoT sensors, data analytics, and communication technologies can improve livestock management. Now, the smart tractors. The next major opportunity is the use of smart tractors. Traditional tractors require continuous human control. So a smart tractor can incorporate technology such as GPS, sensors, automation, connectivity, and intelligent control system. So these technologies can help tractors perform agricultural operation more efficiently. For example, a smart tractor can use location information to follow a planned path through the field. So this can help reduce unnecessary movement and improve the efficient use of resources. When smart tractors are connected with farming data, drones and other agriculture technologies, they become a part of larger smart farming ecosystem. So overall opportunity, it means what is the low overall opportunity from deploying these advanced technology. So we can summarize it in five major areas. Number one, increase productivity. That is, automation and intelligent monitoring can improve farming efficiency. Number two is the better resources management. So data can help optimize the use of water, fertilizers, pesticides, fuel, and other resources. Third is the reduce manual efforts. So robot, drones, and smart machinery can automate repetitive agriculture activities. And fourth is earlier detection. Sensors, drone, and data analytics can help identify potential problems earlier. And the last one is the data-driven decision making. So farmer can use real-time information to make better and faster decisions. So we'll move to the next slide, that is the use of machine learning in agriculture. So agriculture generates a huge amount of information related to crops, soil, weather, pesticides, and farming conditions. Like machine learning can analyze these informations and help farmers make decision making. So in this video, we are basically understanding all those applications of machine learning in agriculture with simple examples. Like first application is crop yield estimation. Suppose a farmer wants to know how much crop can I expect from my field this season. So machine learning can use historical information such as previous crop yield, rainfall, temperature, soil conditions, irrigations, and fertilizer usage. So a regression algorithm can then be used to estimate the expected crop yield. For example, suppose historical data shows that a particular field produces approximately 25 quintal per hectare under certain weather and soil conditions. The ML model can learn these relationships and estimate the expected yield for a new season. So this information can help farmers in future crop planning and productivity improvement. So remember, crop yield prediction, that is known as the regression. So now we are talking about crop species identification. Species, like the second application is identifying different types of crop species. Like imagine a farmer has several crops growing across a large agriculture area. So manually identifying every crop can be difficult. So machine learning can analyze such features like leaf shape, plant structure, color, texture, image captured by cameras or drones. So a classification algorithm can then identify which crop species is present. For example, a machine learning system may classify an image as wheat, that is known as class 1, rice class 2, and maize as the class 3. So this information can support crop plantation and management decision. So the key point is crop species identification is completely satisfied with classification algorithm. Now the third one is crop and weed differentiations. Like now comes another very useful application, differentiating crop from weeds. So weeds compete with crops for water, nutrition, and sunlight with some species. So therefore identifying weeds earlier is very important. Imagine a camera mounted on an agriculture machine. So it captures images of plant in the field. So a machine learning classification model can analyze those images and classify them as crop or weeds. So once the system identifies the weeds, farmer can take appropriate action. So this can support more targeted crop management instead of treating the entire field in the same way. So therefore crop versus weed detection that is possible through the classification. Number fourth is the low cost pest control. The fourth application shown in the slide is the low-cost pest control. That pest can seriously affect crop productivity. So machine learning can help identify pest-related patterns using the agricultural images and one another available data. For example, suppose a farmer notice usually unusually makes on leaves. So an image-based machine learning system can analyze the leaf image and classify it into the different categories. So if the system identify a possible pest problem earlier, the farmer can take prevention or corrective action. So major advantage is that early identification can help in reducing unnecessary intervention and protecting crop productivity. So here again classification algorithm can play an important role. Now the fifth one is the weather forecast. This fifth application is weather forecast conditions. Like weather has a major impact on agriculture. Heavy rainfall and extreme temperature conditions or storm can affect crop production. So ML can analyze historical and current weather information to identify patterns and generate forecasts. For example, based on temperature, humidity, rainfall, and other information, so machine learning forecasting system can estimate upcoming weather conditions. So this can help farmers decide when to irrigate, when to plant, and when to harvest. So when to take precautions against extreme weather. So therefore machine learning based weather forecasting can support better agriculture planning and risk management. Now the last one is decision making support. A farmer has to make many decisions: which crop should be planted, how should the crop be managed, when should irrigation be performed, and what action should be taken when weather conditions change. So machine learning can combine information from different sources and provide data-driven decision support. For example, information about crop condition and soil condition can be analyzed together to help farmers and make better management decisions. So machine learning doesn't simplify provide data, it helps convert data into useful information for decision making. So let's quickly revise today's six applications. Number one, crop yield estimation mainly uses regression. Number two, crop species in the identification, it uses classification. And number three, crop and weed differentiation, again the uses with classification algorithm. Number four is pest control. Classification can help identify pest-related categories. Number fifth, weather forecasting. It uses forecasting technique. So number six, decision-making support. It combines agriculture data to support better crop and soil management decision. So machine learning has the potential to transform agriculture from traditional decision making towards data-driven and agriculture farming, from predicting crop yield to identifying crops and weed, from pest management to weather forecasting, and machine learning can support farmers at multiple stages of agriculture management. So the future farm is not simply about replacing farmers with machines. So it is all about the creating an intelligent ecosystem where drones collect information, sensor generate data, AI and ML analyze that data, robot perform tasks, and smart machinery help farmers make better decisions. So the real power comes when all these technologies work together. So this is the foundation of smart agriculture and agriculture 4.0. Thank you so much, and thank you for so much for watching Kapil Joshi tutorial. If you found this explanation useful, so just like a video, share it with your friends and subscribe to the channel for more easy to understand concept in artificial intelligence, machine learning and emerging technologies. Thank you so much. Bye bye.